Hi guys, we've got a applications of differentiation question to do today. We've got a cubic function that has this equation that's given here. And we're also told that the curve has a turning point at -1, -16. So we've got three parts to this question. Now from memory, I think this one in the exam was worth 2 marks. This one was worth 2 marks. And this one here was worth 6 marks. Now, so you can see that these two here, we should be able to race through them to spend the most amount of time on part C. So we've got to show that A minus B equals 4. So the way that we're going to do this is because we've got Y, we've got A, we've got B, we've got 4 variables in this equation at the top. We need to have an equation in terms of 2. So what we can do is we can substitute in the fact that we know that this curve, when x is equal to -1, has to be equal to 16. So we can sub in these 2 points into this function, and that should give us, and we're going to do a little bit of algebra probably, to give us a function a minus b equals 4. So let's get about doing that. So we've got a. So we're going to have -16 is equal to a times x, so a is x is -1, so we're going to have negative a plus b multiplied by, and we've got -1 minus 1 is -2, squared is 4. So here is what we've done when we substitute these this coordinate point in. Now what we do is we just go about using algebra to make it look like the one we have in part A. So we take the 4 across to the other side and we get -16 divided by 4 is -4 is equal to -a plus b. Now what I'm going to do then is I'm going to times both sides by -1. When I get there, -1 times -4 is just 4. And that's equal to -a times -1 is a. B times -1 is minus b. And that is the solution for the first part of the problem. So you can see that these aren't that tricky if you know what you're doing. And that's why they're only worth about 2 marks. Now it says here, find the gradient function in terms of a and b. Okay, so I'll change colour. So, B, we've got a gradient function that we're going to have to figure out. So, we've got a linear times by a quadratic, so we're going to use the product rule to differentiate this. Now, the product rule from if we have a function y is equal to a times b, we've got two functions times together, the derivative of this, y prime, is going to be equal to the derivative of a times b plus, we leave a the same, and we times it by the derivative of b. Alright, so now using this rule here, we're going to differentiate this. So the derivative of y, so we'll put y prime, is going to be equal to the derivative of the first bracket. So derivative of ax plus b is simply a, and we leave the second part constant, x minus 1 all squared. Then to that we are going to add we leave the front constant, so it's going to be ax plus b, and we multiply that by the derivative of the back. So the derivative of the back was going to be 2 times x minus 1 raised to the power of 1, so it doesn't really matter, times by the derivative of the inside, which is also 1. So this is, you could say that this is the derivative of a function in terms of a and b. You could clean it up a little bit. We can rewrite this as being equal to a bracket x minus 1 squared plus 2 ax plus b x take 1. And so that looks a little bit nicer. And that's the answer for part B. So you can see that these aren't that tricky, the first two parts. Now it says here, find A and B. All right, well, what we have to do is we have to appreciate that the curve has a turning point at this function here, at this coordinate point, sorry. So if it's got a turning point at this coordinate point, what we know is at this point, the derivative is going to be equal to 0, because a function, when it's on a turning point, is flat. So what we do is we're going to substitute in -1, and we're going to substitute in 0 for y prime, and we're going to be able to solve for A and B. So we're going to have 0 is equal to, this is part C by the way. Now, what have we got down here? A times -1 minus 1 all squared, so it's going to be times 4, plus 2 times, then in the bracket we're going to have -a plus b, times by -1 take 1 is -2. Cool. So 0 is going to be equal to 4a. Now we've got -2 times +2. That's -4 bracket -a plus b. We can multiply out this bracket. We're going to have 0 is equal to 4a minus 4 minus a is +4. So it's going to be 8a minus 4b. Okay, now from this equation here, we can say that A is going to equal 4 plus B. So what we can do is we can substitute that into this, and we can go 0 is equal to 8 bracket 4 plus b, close bracket, minus 4b. And this 0 is equal to 8 fours are 32. 8 times b is 8b. So we're left with 0 equals 32 plus 4b. So from here, we're going to move the 32 over the other side. And we're going to divide both sides by 4. Cool. So now we have our b value. And then from that, we can just go straight in and calculate our a value. We know that a is equal to 4 plus b. So a is going to be equal to 4 plus -8, which is -4. Cool. So I hope this video has helped. We've used the fact that a equation passes through a point, and then we've used the fact that the curve has a turning point at that point to get another set of x and y values, so we can solve for a and b using two different equations. So again, I hope that video helped, and I'll see you again next time.